All right, we're going to look at graphing linear inequalities. So, if you recall, an inequality has one of those inequality symbols, greater than, less than, greater than or equal to, less than or equal to. So a linear inequality is just like a linear equation, except instead of an equal sign, it has an inequality symbol. So instead of y equals 2x plus 8, we're going to have y is greater than 2x plus 8. That's all that's different about an equation versus an inequality. The graphs are going to be very similar, but there are going to be some differences because of an equal sign versus an inequality symbol. So a linear inequality goes in that blank. A linear inequality, which is spelled up above, linear inequality, goes in that first blank, is an inequality with two variables, x and y, whose graph is a shaded portion of the coordinate plane bounded by a line. So an equation is just a line. An inequality is going to have a line with shading on one side or the other. The line is called the boundary. The boundary goes in that blank. The boundary of the graph. So when I say what is your boundary, that I'm looking at your line. Your boundary is going to separate your coordinate plane into two halves, into these two sides, one of which is going to contain all of the solutions to your inequality. And you will identify that based on the fact that it will be shaded. So the shading is where all of your solutions are. So how do we graph these? Step 1, plot the points of your inequality as if it were a regular line. If you are in slope-intercept form, you're going to plot your y-intercept and then plot some dots using your slope rise over run. However, step 2, super important in step 2, you are going to connect your points with a dashed line if it's a less than or greater than. You will connect it with a solid line if it is an or equal to. So less than or equal to or greater than or equal to. So dashed if it's not or equal to, solid if it is. Then we're going to choose a test point to figure out where to shade. I'll show you that in the example. Your test point needs to be any point you want it to be that is not on the line. Because the whole point of your test point is to see which side of the line to shade. And so if you're on your line, you're not going to know what side to shade because you've just tested the line itself. So you need to pick something not on your line. You're going to plug it into the inequality that you are given. If you plug it in and what you end up having is true, you are going to shade the side that your point is on. However, if it comes out to be false, you shade the other side. So let's go through this. So we're going to graph our inequality. Y is greater than 3x minus 1. We are in slope-intercept form, so we're going to plot it like we did before. Your slope is 3, which is 3 over 1, and your y-intercept is negative 1. So on your graph, you're going to go to negative 1, put your dot. And then you're going to do your slope of rise 3, run 1. Rise 3, run 1. I went up and right since I'm positive and positive. Now, previously we've said you only need 3 dots. But now I'm going to tell you, you need to go until you reach the edge of your graph in all directions. So up 3 over 1, up 3 over 1. I can't go up 3 over 1 anymore, so I'm good here. But I need to come back here and go the other direction. So now I'm going to go down 3, left 1. Down 3, left 1. So that you have as many dots as you can fit on that line using your slope. Then you're going to connect with a dashed or a solid, which you tell based on your symbol. We said it's dashed if it is not or equal to, solid if it is. So since ours is not or equal to, we are going to be dashed. So when you connect, you're just going to leave some gaps in between. You will still put arrows on your ends. So you got a dashed line. Now we're going to choose a test point. Your test point is allowed to be any place you want it to be as long as it is not on your line. And you need to make very, very sure it's not on your line. So don't pick anything even close to your line, because what if you are off just a little bit in your line? Like right here in between these three, what if I was off just a little bit? Pick something that is clearly not on your line. Also, recommendation, you don't have to follow it. I like to stick in the first quadrant because all of those numbers are positive. Usually that's easier to deal with. Not always, but usually. Any point you want to. I am going to pick this point right here. This is my test point. And I need you to figure out what the coordinate point is. So you can use the same one as me, which I recommend for this example, but you're allowed to use a different one for me if you want to. You're going to follow the same steps, but you're going to use different numbers if you do that. So if you use mine, my coordinate point is 1, 2, 3, 4, 1. So that is my test point. It's 4, 1. I'm going to plug this into the inequality. 4 is an x and 1 is a y. So I'm going to use y is greater than 3x minus 1. I'm going to plug my x in for x and plug my y in for y. So I'm going to do 1 is greater than 3 times 4 minus 1. So I just plugged my y value in for y, kept my greater than, I kept my 3 times, I plugged my x value of 4 in for x, I kept my minus 1. Now, you can't just do this and be done. You have to get it to where it is a single number, an inequality symbol, and then a single number. So we have a single number, 1. We have our inequality symbol greater than. But on our right side, we have 3 times 4 minus 1. You need to figure out what that is. 3 times 4 minus 1. You can just type that in Desmos. If you don't know what it is, just type it in. Do not type this whole thing in. Type just what is after your inequality symbol. 3 times 4 minus 1. Well, 3 times 4 is 12. 12 minus 1 is 11. Okay. Once you are to this point, now you're going to read this statement out loud, and here is where you need to know what that inequality symbol is. If you don't remember, you make them with your hands, because your left hand is the less than sign. Does this symbol match this hand? No. It matches my other hand. So if the left hand is the less than, and that doesn't match it, then that's a greater than sign. So this says 1 is greater than 11. No, it's not. 1 is not greater than 11. So if this is not true, then I do not want to shade this point in, because this point is not a solution. So instead, here's my line. I have this part of my graph, and I have this part of my graph. I do not want to shade this point in. I want to shade in the other side of my line. You want to make sure you do not cross over your line you drew in. But you do want to cross over your x and y axes. We're not focusing on what quadrant are we in. We're focusing on which side of the line that you drew. So we are on our side kind of to the left of that line. What this graph shows you are all of the solutions. Every single point over here and beyond in that direction is a solution to that inequality. If I would have done a test point somewhere over here and plugged it in like I did here, anything over here should have come out to be yes, and anything over here would come out to be no. Example 2. Graphing your inequality. Starting by plotting your points. Our y-intercept is 1. Our slope is negative 2 over 5. So from that point, you are going down 2 and right 5. Down takes care of the negative, so you're going to go a positive in your run direction. So down and right, which I can't continue anymore. I could go down 2, but I can't go right anymore. Then we're going to rise 2 and run now left 5. That's as far as I can go that direction. Now we are going to connect solid or dashed. Looking at our inequality symbol, this time we have the or equal to, so that's going to let us know we are solid. So connect those with a solid line. Arrows on the ends. Then you need to pick a test point to decide where to shade. Your test point is allowed to be wherever you want it to be. You do not have to pick the point that I am about to pick. I'm going to pick this point up here. Why? Just because. That's the point I want to use. My point is 1, 2, 3, 4, 5, 3, which is x, y. I'm going to use my inequality that I have up here. I need to plug 5 in for x, 3 in for y. Make sure you have a time sign there. We need it to be number, symbol, number. We don't have that, so we're going to do 3, which is fine, symbol, which is fine. But all of this, we need to type into Desmos. -2/5 times 5 plus 1. Type it into Desmos. If you do, you should get -1. Now we're going to read this and see what it says. We need to know our symbol, and if you don't know it, you make it with your hands. This symbol looks like my left hand, which is the less than. So is 3 less than or equal to -1? No, it's not. 3 is not less than, and 3 is not equal to -1. So no, doesn't work. So is this point a solution? No. So should we shade it? No. So you're going to shade the other side of your line, which is kind of everything below. So everything up here is not a solution.
Rayshawn, Garrett, can you please come to the office?
Everything down here is. So if I asked you, is -2, -3 a solution? Once you have your graph, you do not need to test it like this. Once you have your graph, you go to that point. -2, -3 is right here. Is that a solution? Yes. How do you know? It's in the shading. That's all it is. Graphing your inequality, y is less than or equal to 4. Plotting your points. If you recall from the lesson you just did, when you have just y and no x, your line should be a horizontal side-to-side line. You're just going to go to where y is 4. You're going to go side to side. We do need to pay attention if it's dashed or solid. Has an or equal to, so it's solid. So straight across with a solid line. Now we're down to our test point. I'm going to use 0, 0. I like 0, 0. 0, 0 is really easy to use most of the time. You can only use it sometimes because sometimes 0, 0 is on your line, or sometimes 0, 0 is really close and you're not sure if it's on your line. So I use it in those cases. But this one, it's definitely not on that line. Here's my x. Here's my y. Here's my inequality I need to use. I need to plug 0 in for y. You don't have an x anywhere in this inequality. So you are not going to plug this x anywhere in that inequality because you're not supposed to. There's nowhere to use it. All you got to use is your y value. So you're just going to plug in 0. We have number, symbol, number. We don't have anything we need to do other than read it. Looking with our hands, our symbol matches my left hand, so that is a less than. Is 0 less than or equal to 4? Yes it is. So should we shade where that point is? Yes, we should. So not just here and below, because we need to start at our line, at your line and everything below. So then if I asked you, is 5, 9 a solution? What would you say? Is 5, 9 a solution? What would you say to that? Yes or no? How do you know? Well, if you go to 5, 9, I don't know exactly where it is, but it's somewhere up here. Is that a solution? No. How do I know that? It's not in the shading. X is greater than -2. So kind of similar to this one, except now I'm X. I'm going to go to -2. Solid or dashed? In this case, dashed, because it's not or equal to. And with this one being X, we're going to go up and down. Test point. I'm going to use 0, 0 again. The 0, 0 is definitely not on that line. Similar to before, I only have one variable. I only have X this time, so I'm going to plug in X. I don't have anywhere to plug in Y, so I don't need to do that. I have number, symbol, number, so I'm done with that. I just get to read it. I look at my hands. This looks like my right hand, so that must be a greater than. Is 0 greater than -2? Yes, 0 is greater than -2. So I need to be on the side of my dot, so from my line and over. And your last one. Now, this is in standard form, and you had 2 methods for standard form. So I need you to pause the video and do this with your teacher. All right? Because there are 2 ways to do standard form. There are 2 ways to graph standard form. And I need you, I don't want to have to do 2 on the video. I'm going to just do 1 with you. So if you remember how to do it, it's literally the lesson you just got done doing. If you remember how to do that, then do it. Go forth, try it on your own, but then get it checked because there's possibly some mistakes you might make. If you try it on your own, when you go to do your test point, make sure that when you do your test point, you take your X and your Y and you plug it into this inequality right here. Nowhere else. This one right here. That's where your test point needs to go in. All right. So either try it on your own and get it checked with your teacher, or just do it with your teacher. So I don't have to do it twice in the video.